Hi ladies, it's Mr. O'Sullivan. I'm sorry that I'm making this video today. I know we just had Zoom, but if you missed Zoom, please watch this video. That way you can get a better understanding of what's going to be expected of you when you do this lesson. So today's learning target is, I can use translations to perform transformations on points and figures. When we started the Zoom, a lot of you actually told me that you learned about translations a few years ago, which is true. You learned about them in middle school. But now we're in high school, so we're going to learn about them from a high school perspective. So please know a translation is simply just a transformation that slides all points of a figure the same distance in the same direction. So I'm going to be going left to right and up or down. So if I look at my image over here, I started with triangle ABC and then I slid it down and to the right to get triangle A prime, B prime, C prime. And remember, whenever we transform a figure, we always have to use our prime notation. The more primes it has, the more transformed it is. So there are some notations that are going to be a little different, so you might not have seen all these notations in middle school, but a few of the notations I'm going to expect that you are familiar with are verbal descriptions, coordinate mappings, and translation notation. So when you're given a verbal description, you're simply just given a sentence saying, oh, Nicole, translate this figure 7 units to the left and 3 units down. So please pay very close attention to the language being used. I could also give you a coordinate mapping and say, hey, Jael, please move this object -7, -3. But what exactly does that -7, -3 mean? So basically what you're doing is you're basically going to be given your ordered pair right here. So you're giving your ordered pair, and I'm telling you, start with your x value and take away 7, and then take your y value and subtract 3. That's going to be your new transformed point. And then last but not least, another way of translation notation is simply writing the big letter T and then putting some numbers next to it. So for instance, I have a -7, -3. I'm going to write it a little bigger. And that -7 corresponds to my x value, and that -3 corresponds to my y value. All of the descriptions in this box, the description, the coordinate mapping, the translation notation, all that goes back to 7 units to the left and 3 units down. Occasionally you can have a combination of those above, or you could even use these things called vectors, which we'll see in an example shortly. I'm not going to give you vectors, but they do pop up occasionally. And we'll go over it. It's very straightforward. Here's the big idea though. Regardless of the notation used, the first number represents the horizontal slide and the second number represents the vertical slide. So horizontal, you might have heard me say hooivuks last year. Horizontal is going to look like this. So here's my horizontal line. And if I'm going to the right, that's going to be my positive. And when I'm going to the left, that's going to be my negative. So the -7. Now, the second number represents my vertical slide, so going up or down. So when I do my vertical slide, it's going to look like this. So my vertical slide is going to look something like this. And when I do that, 1 second, it's going to be a straight line going up, so that's telling me right here that I'm going to have my positive and my negative. So when I'm positive, I'm going up. When I'm negative, I'm going down. Okay, let's do some examples. So in these directions, what's nice about these problems is you just have to count. So in the first example, we want to basically move that triangle 5 units to the left and 2 units up. So please, 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 ladies, pay very careful attention to how much you're counting. So when I count, all I do is I basically put my finger on each of these points right here, and I'm going to go 5 to the left and 2 up. So let's show how we count. I'm going to count my jumps. This is a jump of 1, a jump of 2, a jump of 3, a jump of 4, and a jump of 5. I'm now going to go 2 up, 1, 2, and here's where I'm going to plot my new point. Let me do some erasing. Now I want to move my other point 5 units to the left and 2 up. So I'm going to do my counting one more time. So 1, 2, 3, 4, 5. And now I'm going to go 2 up, 1, 2. And that's my new point. I'm going to do some erasing one more time. Now we're going to go to our last point, and we're going to go 5 units left one more time and 2 units up. So 1, 2, 3, 4, 5, and 2 up. So right here. I'm now going to take out my straight edge, and what I'm going to do is I'm going to connect those points. We need to make sure our image looks the exact same or extremely similar to what we started with. And boom, I connected my points as best as I could. I started with a triangle and I ended with a triangle. What was really nice in class today, I didn't even pick up on this, but I believe it was Amma and Allison immediately mentioned that, look, I started with a triangle and I ended with a triangle. So whenever you have a translation, you're going to start with the same figure and end with the same figure. I can't make a square out of a triangle as much as I would like to. Okay, so now we go to this example. This is an example of vector notation. So whenever I start with my first number, we said this before, the first number always represents your horizontal, and your second number always represents your vertical. So my 3 is positive, so I'm going to be going to the right 3. And my 0 is telling me that I'm going to go up or down 0. So I'm basically going nothing with my 0. So I'm just moving my figure 3 units to the right. So I'm going to count my image. So I basically go to my points, go to my points, go to my points, go to my points. And I'm just going to move those points 3 units to the right. So I'm going to start with this point right here. So I go 1, 2, 3. Let's start with this point now. So 1, 2, 3. Start with this point now. 1, 2, 3. And then this point right here, 1, 2, 3. I'm now going to connect those points with a straight line. And that's my final answer. I moved my image 3 units to the right, and I did nothing to it. I didn't move it up or down, I just moved it 3 units to the right. And that's an example of vector notation. Okay, now what we want to do is we want to do something else. We want to be a little different. What we want to do is we want to look at the vertices of triangle ABC, which are A11, B27, and C42. And we want to graph triangle ABC and the image of triangle ABC under the translation of T23. So here's what I'm going to do. The first thing I do is I always rewrite my ordered pairs that I start with. So I'm going to write A11, B27, and C42. So A11, B27, and C42. So when I write those, I now want to go ahead and plot them. So I'm going to plot those points right here. If you don't know how to plot points, please make sure you do your delta math practice. I'm going to be plotting them secretly. So I plotted my triangle perfectly, well, as close as it can be. And now what I want to do is I want to graph triangle ABC and the image of triangle ABC under the translation of T23. Here's what I do now. I'm going to draw an arrow. So if you were in the Zoom, you saw this already. I draw an arrow going from each ordered pair. And what I like to do is I like to rewrite the rule above each arrow, because once we progress further in this unit, I'm not going to have you just do one transformation. I'm going to actually have you do like 2 or 3 in a question. So what I'm going to do is I'm going to rewrite that translation rule above each one. I'm going to write it just like that. And now I like to color code. So I'm going to do my new image in green. So I want to plot points A prime, B prime, and C prime. So I have A prime, B prime, C prime. And the reason why I put a prime is because this is the plastic surgery unit. We are transforming our figure. So the more primes we have, the more distorted or transformed our figure actually is. So our 2 is positive and our 3 is positive. Remember, 2 goes with X, 3 goes with Y. So what you're saying is, I want to take my 1 and add 2 to it. Well, what's 1 plus 2? It's 3. I'm now going to take my 1 and add 3 to it. What's 1 plus 3? It's 4. So A prime is 3 comma 4. I'm going to do the exact same thing for B prime. I take my 2, I add 2 to it. 2 plus 2 is 4. I take my 7 and I add 3 to it, and I get 10. Note, everything's positive so far. These are some nice numbers. I'm now going to take my 4 and do 4 plus 2, which is 6. I'm going to take my 2 and add 3, which is 5. So these are the points I'm going to plot. I'll actually model how to plot these. So for A prime, I'm going to go to the right 3 and up 4. So 1, 2, 3, 1, 2, 3, 4. Here's where A prime is. I'm now going to plot B prime, which is 4 comma 10. So I go to the right 4, up 10. So 1, 2, 3, 4, up 10. And now I'm going to plot C prime, which is 6 comma 5. So I go to the right 6, up 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. C prime. I'm now going to connect my points with lines. Let's see what it looks like. And that's triangle A prime, B prime, C prime, and that's your final answer. Okay, what do you notice? What do you see? What do you think? Well, I see two triangles, so that means I did my translation correctly. I see a triangle that's been moved 2 units to the right and 3 units up. And it just looks the exact same. It's just a little up. It's slid over. Okay, let's go on to the next example. So this one's a little different. Graph triangle ABC with the vertices A -3, 4, B1, 0, C2, 3. Find the image of triangle ABC after the translation, where you do x plus 2, y minus 4. So I'm going to be adding 2 to my x value, or going right 2, and then going down 4, or subtracting 4 from my y value. So let's put this. So I'm going right 2 and down 4. Okay, what I'm going to do is I'm going to plot my original image. Well, first I'm going to write the coordinates. I'm going to write A -3, 4, B1, 0, and C2, 3. So now that I have my points written, what I'm going to do now is I'm going to plot these points on the coordinate plane. I didn't do this before, but Miss Kimmick has the best trick ever. This is my plus plus quadrant. This is my minus plus quadrant. This is my minus minus quadrant. And this is my plus minus quadrant. So if you are a student who struggles with plotting points, use that to your advantage. Remember, you're just starting at your origin, then going in the direction you need to. So I'm now going to plot the points. So I'm going to plot -3, 4. I'm going to do this in red. Well, I'll name them in black, but I'll draw my figure in red. So I go out 3, up 4. So 1, 2, 3, 1, 2, 3, 4. I'm now going to plot 1, 0. If you missed the Zoom, you missed a very good discussion on why this is 1, 0. Just a heads up. And now I'm going to go to 2, 3. So I'm going to go out 2, up 3. And this is C prime. I'm now going to connect those points with red lines. Please watch. So I have triangle ABC plotted. Now what I want to do is I want to perform my transformation. Note, I'm not saying translation because it's not always going to be a translation. In this case, yes, I will be performing a translation, but it might be a reflection, it could be a rotation, it could be a dilation, which we'll be going over shortly. So as I did before, I'm going to draw an arrow going from each point. So I'm going to draw an arrow for my A, my B, and my C. And I'm going to write my rule above it. So in this case, my rule is x plus 2, y minus 4. What you can do is you can put your x plus 2 on one line and your y minus 4 on the other. That's what I do just for space purposes. X plus 2, y minus 4. Okay, and now what I'm going to do is I'm going to basically say, Mr. O'Sullivan, add 2 to your x value, subtract 4 from your y value. So, I'm now going to do A prime, B prime, and C prime. So A prime, -3 plus 2 is -1. 4 minus 4 is 0. For B prime, I have 1 plus 2, which is 3, and 0 minus 4, which is -4. And then last but not least, I do 2 plus 2, which is 4, and then 3 minus 4, which is -1. I'm now going to go over and plot these points. And that's my triangle plotted, triangle A prime, B prime, C prime. So now we're almost done. We now need to just look at the properties preserved under translation. Well, we know that our distance is preserved because we're not really multiplying or dividing, we're just adding and subtracting. So my side lengths will always be congruent. My angle measures are also always going to be congruent. Parallelism. My pre-image and its image will remain parallel. Let's look. Well, let's just look at a segment. Let's go to one of these ones from above. In class today, what we did was we looked at our AC, and we want to see if it is parallel to A prime, C prime. So we know to be parallel, our slopes have to be the same. So I can find my slope of AC by using rise over run. So I rise 1, and I run 1, 2, 3. So my slope is 1/3. If I want it to be parallel to A prime, C prime, it also has to be 1/3. Let's check. So 1 is my rise. My run is 1, 2, 3. So my slope here is also 1/3. So I can say line segment AC is parallel to A prime C prime. So I can say that parallelism is preserved. And last but not least, my orientation. I'm asking you, is my A still to the left of my C? Yeah, it is. Is my B still downstairs? Yep, it is. So my orientation is also preserved as well. And that's it for today. If you have any questions, please email myself or attend an extra help session with Miss Daniel Monday, Wednesday, or Friday during second period. Don't forget to work on your Delta math. Have a great day, ladies.